So good morning. So today we will be learning the Mathematics 7 Module 7, the principal roots and irrational numbers. So to begin with, we have set of objectives to be followed. So we have define the principal root, describe the principal roots and tells whether they are rational or irrational. We are going to determine between what two integers the square root of a number lie. So lesson 1 would tell us the first and second objectives, while the third objective would tell us in lesson 2. So lesson 1, the principal roots and its nature, the rational and the irrational numbers. So we will begin this one by focusing on the multiplication table. So if you look at the multiplication table, the red one was being multiplied to the blue numbers, and the output are the grays and the green. So focus yourselves on the green numbers, and these green numbers are the product of the same factors. For example, the first factor is 1. 1 times 1 and 1 are the same numbers. The answer is also 1. 2 times 2, the answer is 4. 3 times 3, the answer is 9. 4 times 4, the answer is 16, and so on and so forth. The output here, 1, 4, 9, 16, 25, 36, 39, 64, 81, 100, and so on and so forth, are what you call perfect square numbers. And these are numbers that are, the definition is the square of a perfect square is the square of a rational number. So principal root is a number which produces a specific quantity when multiplied by itself. So a number being multiplied by itself, that is what you call the principal root. When you say root, that is the answer in a radical expression or a radical solution. It is positive nth root of a number. Principal root is considered always positive. But when you say root, it considered be as positive or negative. So next, rational number is a number that can be expressed in the form a over b. Again, in the form a over b. When you say a over b, that is a fraction with a numerator a and a denominator b, where a and b are integers and b is not equal to 0. Now take note, irrational number is a number whose decimal representation is neither terminating nor repeating. This number cannot be expressed as a quotient of integers. So when we have rational number, usually it is in the form of fraction. And when you say irrational number, it is usually cannot be expressed in fraction. Example of these are as follows. So let's analyze square root of 36. Square root SQRT can be read as square root. So we have square root of 36. Let's begin with number 1. Square root of 36. So the answer is positive negative 6. Where did we get this one? Now take note, we have the perfect square numbers in the multiplication table. So we have 1 times 1, or 1 squared is 1, 2 times 2, which is 4, 3 times 3, which is 9, 4 squared, or 4 times 4 is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 times 8 is 64, 9 times 9 is 81, 10 times 10 is 100, and so on and so forth. Marami pa po yan siya. So, paano natin ikuha si 36? How did we get positive and negative 36? Or plus minus 6? So, square root of 36. 36 is this one. The root is 6. So, we are going to write 6 here. Next, number 2. Square root of 64. So, before we proceed with number 2, this 6 is a fraction. And this is, how do we know if it is a fraction? Fraction is considered a over b. And 6 has a numerator 6 and denominator invisible 1. So this is 6 over 1. So this is an example of a rational number. Next, square root of 64. We have 64, 8. So we have plus minus 8. And this is an example of a rational number. 8 over 1. Next, square root of 2. Square root of 2. Square root of 2. So 1, 4, 9, 16, 25, and so on and so forth. There is no 2 on this side. on perfect squares. So therefore, we could say immediately that it is an example of an irrational number. But how do we get the numbers here or the root? So using your calculator must be in landscape format, or you're going to rotate that one, and the symbol is usually the symbol is for the calculator. Usually the symbol is square root of x or square root of x. Then it has 2 here, or simply like that. These are all the same, square root. Okay, next. Square root of 2. Let's try square root of 2. Square root of 2. The answer is 1.41, So, and it never ends. It is continuously infinitely many. So, we have 1.41. And if it is infinitely many, you may write the first two or first three numbers, then proceed with 3 dots. And this is an example of irrational number. We could not express this one into fraction because it is infinitely many and at the same time non-terminating. So next, square root of 50. Square root of 50. This one, if you look at the list of perfect squares, there is no 50. We only have 49 and 64 or 36. So therefore, we could immediately write irrational number. This is an example of an irrational number. So square root of 50. Square root of 50. So we have 7.07. We have 7.071 and so on and so forth. So that is it. Next, square root of 81. Square root of 81. 81 has a perfect square, which 81 is a perfect square, therefore it is a rational number. Rational number with plus minus 9 as her roots. Next, square root of 75. For the square root of 75, there's no perfect. 75 is not a perfect square, so we could write immediately that it is an irrational number. And square root of 75 is square root of 75. That is 8.66. Again, square root of 75 is 8.66, and so on and so forth. Okay, that is now an example of rational and irrational number. So, moreover, so what we did a while ago is we identify the principal roots of whole numbers while some are decimal numbers. Now, when a principal root is a whole number or a fraction similar to this one, 6 is also a fraction because it has a denominator invisible over 1, then the principal root is described to be a rational. So, this one, and this one are rational numbers. At the same time, when it is non-repeating decimal and terminating decimal, then it could be an irrational number. Example of these are the 3. So that ends our lesson number 1. Thank you.